All right, continuation of 8.3. This is day 2 notes showing that a quadrilateral is a parallelogram. So we're still working with those same theorems. The definition of a parallelogram, both pairs of opposite sides are parallel. Theorem 8.7, both pairs of opposite sides are congruent. 8.8, both pairs of opposite angles are congruent. And 8.9, one pair of opposite sides are congruent and parallel. And 8.10, showing that the diagonals bisect each other. So there are some formulas that we're going to have to use, so we need to review those. So write these down so you can remember them. The distance formula, we'll use the distance formula. Oh, that's not right. Let me get that figured out. All right, so distance formula is d for distance equals the square root of a bunch of stuff here. So make a long square root sign. We have x2 minus x1 squared plus y2 minus y1 squared. Remember those x2, make sure you're matching up the points. So your x2 and y2 is one point, x1 and y1 is one of your points on a graph. Make sure that's matched up properly. And then the slope formula. We want to be able to find slope of some lines. So remember slope formula. Slope is always represented as m for slope. M equals y2 minus y1 over x2 minus x1. And that is also rise over run. Use rise over run to remember you're putting the y's on top and the x's on the bottom. So distance formula and slope formula. So example number 1, we want to prove LMNK is a parallelogram by showing both pairs of opposite sides are parallel. So we need to show both pairs of opposite sides parallel. So we're looking at that definition, number 1 up there. So if I want to show both sides parallel, for them to be parallel, think back to when we did parallel slopes of parallel and perpendicular lines. What was the relationship of slopes between parallel lines? They always had the same slope. Remember, parallel lines have same slope. Perpendicular lines had opposite reciprocal slopes. Do you remember that? So parallel is same slope. So if we can show that the slopes of each of these lines are parallel to their opposite side, then we're good. So slope of KL. First, let's look at KL. So we want to use our slope formula here. So we'll have y2 minus y1. So 4 minus 2 over x2 minus x1. 4 minus 2. That's just 2 over 2, which is 1. So our slope of KL is 1. 1 over 1. Then we need slope of NM. That's the opposite side. So we take y2 minus y1. So 0 minus negative 2. Don't forget the double negative there will turn into a positive, and then 6 minus 4. So that becomes 0 plus 2 on top. So we get 2, and 6 minus 4 is 2. So we get 1. So the slopes of our first set of opposite sides are both 1. So they are parallel. Then we want to find the slopes of our other sides. So if I look at LM, Slope of LM, we've got 4 minus 0. Those are our y's subtracted. And 4 minus 6, or x's subtracted. So on top we have a 4. On the bottom, a negative 2. So that's going to simplify to just negative 2, or negative 2 over 1. And then our last one is Kn. Slope of Kn, we'll have 2 minus negative 2 on top, our y's subtracted, and 2 minus 4 on the bottom, our x's subtracted. So that on top becomes 2 plus 2, negative, and negative makes a positive, which gives us 4, and 2 minus 4 gives me negative 2. So that again is negative 2, once 4 over negative 2 is simplified. So those slopes are equal, so those are parallel as well. So we've got two sets of opposite sides parallel. We know KL was parallel to NM, and we knew LM parallel to KN. Example number 2, we want to prove LMNK. Same figure from example 1 as a parallelogram, but this time by showing that both pairs of opposite sides are congruent. So in this time we have to use the distance formula. So even though it's the same figure, and we know it is a parallelogram because we proved that in the previous one, this one specifically wants us to use and show that both pairs of opposite sides are congruent. So we're going to use distance formula. So looking at KL first, I have to write in the distance formula. So that long square root. Then I've got my x's subtracted together, so 4 minus 2 in parentheses squared. And my y's subtracted together, 4 minus 2 in parentheses squared. KL will equal 2 squared plus 2 squared. 2 squared is just 4, so 4 plus 4 is 8. So KL is the square root of 8. Then we want to see that NM, we need to show that those are congruent, the two red lines, that they're congruent. So NM plug into the distance formula. Our x's would be 6 minus 4 squared plus 0 minus negative 2 squared. So 6 minus 4 gives us 2. So we've got 2 squared plus 0 minus negative 2 becomes 0 plus 2. So that gives us 2 squared. So again, NM, see that is the square root of 8. So it does show that KL is congruent to NM. And then we need to show the other two sides. So let's look at KN. We've got our x's. 2 minus 4 squared plus 2 minus negative 2 squared. Two minus 4 squared gives me negative 2 squared. And 2 minus negative 2 becomes 2 plus 2, so that gives me 4 squared. So negative 2 squared is just 4. And 4 squared is 16. So Kn equals the square root of 20. So then I need to show that Lm equals the same. My long square root sign, plug in my points, my coordinates for Lm. I've got 4 minus 6. That'll be squared plus 4 minus 0. And that'll be squared. So 4 minus 6 is negative 2, so we've got negative 2 squared. And 4 minus 0 is just 4, and that is squared. So Lm also equals the square root of 20. So Kn is congruent to Lm. Example number 3, we want to prove that WXYZ is a parallelogram by showing one pair of sides are congruent and parallel. So one pair of sides are congruent and parallel. So that's just like our 8.9. One pair of sides are congruent and parallel. That's what we're trying to show. So we just need to pick one pair of opposite sides. Pick one pair of opposite sides. So we could go about this two different ways to show it. We could either show ZW and YX are parallel and congruent, or we can show ZY and WX are congruent. So I'm going to use ZW and YX. I'm going to look at ZW and YX. And I want to show that they're congruent, and I want to show that they're parallel. So first, I want to find the slope of ZW. Remember our slope formula, rise over run, our y's subtracted over our x's subtracted. So 4 minus 2 on top, 2 minus negative 1 on the bottom. That gives me 2 over 3. So the slope of ZW is 2 over 3. And we need to find the slope of YX. So on top I've got 2 minus 0. And on the bottom my x is 6 minus 3. 2 minus 0 is 2. 6 minus 3 is 3. So my slopes are the same. So ZW is parallel to YX. ZW is parallel to YX. Now I need to show that they're also congruent. So I'll need to use the distance formula to show that they're congruent. So ZW, distance formula with that, is my x's and my y's Okay, just plugged into the distance formula. 2 minus negative 1 gives me 3. So I've got a 3 squared plus a 2 squared. So that's 9 plus 4 is 13. So the square root of 13 is ZW. So I need yx to also come out to the square root of 13. So I've got my x's, 6 minus 3 squared plus 2 minus 0 squared. That gives me a 3 squared again, plus a 2 squared. So we do show that those are congruent as well. So ZW is congruent to YX. So we're able to show both, that they're parallel and they're congruent. So we were able to prove WXYZ is a parallelogram. All right, and then our last example here. We have 3 vertices of parallelogram ABCD, which are given. We need to find the coordinates of our 4th one, point D, and we'll show our method. So first I'm just going to plot those points. A is at negative 4, 1. So 1, 2, 3, 4, up 1, left 4, up 1. That's at point A. Point B is negative 1, 5. So left 1, up 5. Point B. Point C is 6, 5. So to the right 6, up 5. Point C. And then D is what we need to figure out. X. We need to figure out the X and the Y of point D. But this time we know it's a parallelogram. We're told it's a parallelogram. So we need to show one of our methods. We use one of our methods. So either we can use our distance formula or our slope formula. We need to be able to find either the slope from C to D, or find the slope of A to B, and then use that same slope with C to D. Or we can find the distance between B and C, or A and B, and find the distance between A and D, and use that to show the distance from A to D. Because we know BC is going to be the same distance as A to D, wherever D is, and we know the slope of AB is going to be the same as the slope of DC. So either one. So I'm going to use the slope of AB, and then I'll recreate that on the other side to find my point. So slope of AB, I can just count up, or I can use my slope formula. So if I'm looking at slope of AB, I guess just write it all out. We have rise over run, so 5 minus 1 over negative 1 minus negative 4. So that will give us 4 over negative 1 plus 4 is 3. So I should have a slope of 4 over 3, a rise of 4 and a run of 3. So if I go back to the graph here and count up, I should be able to count up 4 and write 3. 1, 2, 3, 4. 1, 2, 3. So it does have a slope of 4 over 3. So to show this, to find D, I would have to do that in reverse. I would need to go down 4 and left 3. Because remember, we can also show our slope as -4 over -3, going the opposite direction. Down 4, left 3. That still equals, because the negatives would cancel out to make it positive 4 over 3. So I count down 4, 1, 2, 3, 4, and left 3, 1, 2, 3. And so I know my point D is right there. And then I just need to count and see what it actually is. It's 1, 1, 2, 3 to the right. So my x value is 3, and it goes up 1. So the point for point D is 3, 1. All right, that's it on the notes. Make sure you do your homework.